Lester, Wushu Engineer. Some time ago, I made a video on how to set up a do-it-yourself isometric force feedback strength training gym using simple and cheap digital crane scales that are available from many places online for under $100. It was quite a popular video, and my viewers requested that I provide more detail on how to adapt the crane scales for these purposes. So I followed that video up with a lengthy and detailed video demonstrating step by step exactly how to adapt a crane scale for this purpose. And essentially what it involves is taking the crane scale apart, removing the load cell component and separating the display component so that the display component can be used to provide easily visible feedback to anyone using a machine or an apparatus that the load cell is mounted within. I have also uploaded many videos referencing scientific studies that have reported on the strong relationship between isometric strength and both dynamic strength, such as it demonstrated in weightlifting, and explosive power, such as demonstrating in jumps and plyometric exercises. I encourage you to watch these older videos for greater context to this video, because I'm not going to explain how to adapt a crane scale in this video, nor am I going to reference any scientific studies that justify the use of isometric training. In my previous video, Build Your Own Digital Force Feedback Isometric Strength Gym for under $100, I said the following. One idea that I'd like to try is incorporating one of these into a simple one-armed training dummy, a rigid dummy, to enable the use of the dummy to get some kind of force feedback values for various China style manipulations, locks and holds performed against the dummy's arm. I have since then built that training dummy. I know, there are a lot of projects that I've mentioned in my previous videos that I wanted to get to and I haven't actually touched just yet. I'm busy. But I've also really been enjoying testing out this force feedback dummy and using it in some of my own personal training. So I thought I would share it with you in this video. It's a lot of fun to use. Let me introduce you to Legless Bob.
Condemned to a watery grave with a captain who's legless. Rubbish! I've hardly touched a drop.
Now, Legless Bob is a training dummy that provides the user with sensible digital force feedback based on how much force the user exerts against an analog of a human arm with a load cell located at the analog elbow joint. The load cell and digital display is taken from a digital crane scale that can be bought relatively cheaply online and modified with ease to suit the purpose. The digital display is placed at a convenient height so that the user can easily see their force output while using the dummy. Now this is important because it's important not to have the display in a hard to see location, because that will negatively impinge on the user's performance and the training feedback benefits that they will enjoy. I typically just use adhesive strips of Velcro to temporarily mount the display in a visible location based on whatever isometric training equipment I'm using. It should be borne in mind that one of the limitations of this design is based on the inherent limitation to these cheap digital crane scales, and that is the sampling rate. These digital crane scales have a relatively slow sampling rate or low sampling rate, so it only allows for the crane scale to register slower sustained forces applied against it. It's not designed to register rapidly applied impact forces such as in strikes, for instance. So this must be borne in mind when Legless Bob is used in training. Don't hit Legless Bob. Grappling speed movements should be applied only, although these can be applied with typical speed that will be associated with grappling techniques when used in sparring. So I originally thought to build a very complicated, multi-jointed, multi-limbed dummy that could be used either from a standing position or from the ground. Typically when I design and build something, I start with an overly complicated design and then kind of streamline it down over time and strip it down to its bare essentials. I tend to over-engineer prototypes, hence my channel logo subtext. Over-engineering martial arts. So I decided to streamline and simplify my original idea, which, as I mentioned, involved slapping load cells all over a complicated, multi-jointed dummy, and instead decided to concentrate on building a very simple, single-jointed analog of a human limb. I decided that the single-jointed dummy limb would offer the most utility and versatility. I originally thought to build the concept dummy out of steel, but I eventually decided that structural pine would have sufficient strength and be easier to implement and simpler to change and refine during the prototyping stages. And while I believe that my design absolutely can be further improved, it is now simple to construct, easy to use, and extremely versatile and very intuitive in terms of its training applications. The inset detail shows a basic construction diagram of Legless Bob and his shoulder joint. It's not thoroughly and minutely detailed, but it should give someone sufficient information to work out how to build their own version of Legless Bob. If there is sufficient interest, that's in the comments section below, I will make the design document more comprehensive and I'll upload it for free to our Wushu Workshop website. So let me know if you want me to do that. The Legless Bob rig consists of a pair of MGP-10 pine battens that mimic the upper arm and the forearm of a human arm, and that are separated by a 4mm thick G10 fiberglass strip which acts as a spring elbow joint. If unimpeded, would allow the limb to bend as a normal arm bends. But it's held in place by the load cell on the other side of the joint and represents a fully extended elbow joint. So the spring joint is actually not allowed to bend because it's opposed by the load cell on the other side of the joint. Any kind of bending forces are thus transmitted into the load cell and provide digital feedback to the user. This feedback, I must stress that this feedback is not reflective of the actual amount of force that a natural human elbow would be placed under, because the human elbow joint is mechanically dissimilar to the joint that I've constructed for Legless Bob. It's a lot more complex than Legless Bob's elbow joint. And it's more likely actually that a human elbow joint locked in an extended position, as Legless Bob's elbow is, would experience a lot more force, at least in certain locations, than Legless Bob registers, because of the human elbow joint's relative complexity and fragility compared to the simulated analog elbow joint. However, the feedback that Legless Bob provides is not meant to be a direct and accurate account of the force that a human elbow joint would encounter, but is instead meant as a training tool. It is meant to provide a force output that scales effectively with the human user force input to allow for training progress to be made and monitored. Legless Bob's arm is connected via a free-moving shoulder joint to a movable mounting platform that can be raised and lowered on a steel column to any desired height. The shoulder joint allows Legless Bob's arm to be freely twisted and swung in a 360-degree arc. I originally wanted an unfixed dummy that could be used both standing and on the ground, but opted for the simplicity of a dummy limb fixed on a platform, because the platform allows you to raise it and lower it to any desired height. This allows legless Bob to transition into armless George. In other words, the arm analog can be used as a leg analog simply by lowering the platform until the limb is hanging from roughly hip height. In addition, the platform can also be lowered until legless Bob's shoulder joint is located just above the ground, which does allow for certain ground-based grappling locks and holds to be used against it. Finally, although legless Bob has been designed specifically for use with bare hand grappling techniques and applications, with some modification there is a potential for it to be applied to weapons training. By using the arm as a sword or a club weapon analog, the load cell can provide force feedback that scales with the amount of force that the user can exert with either a one or a two-handed grip. This can help a weapon user to build and improve on the amount of sustained force that they can commit to a weapon strike in whatever direction they wish to strike in. The rig and legless Bob's free-moving shoulder joint allows for full 360 degrees of weapon striking angles to be applied at various heights. This can also be used to train a user to apply high levels of torque through their wrist and elbow joints, in much the same way as training with heavy Indian clubs or using hammer holding isometric exercises would. So without further ado, let me talk you through some of legless Bob's aspects and get the Wushu Scientist to demonstrate some training techniques on him. So this is legless Bob. Legless Bob has an arm with a shoulder joint. It's just a passive shoulder joint, a sensor, a load cell from one of the crane scales built into an elbow joint, going up to a digital display which shows you how much force is being experienced by the load cell at the elbow joint. As you can see, I used simple MGP10 wooden
Battens?
wooden battens. That's what they are. As I said, just a simple passive shoulder joint here at the moment, but I am planning on, I'll speak about it a little bit later in the video, but I am planning on making this joint, putting a load cell into this joint as well to give some force feedback into the shoulder. But anyway, as it is at the moment, just the elbow joint has a load cell on it. The joint is immobile, it doesn't move. It has a, maybe you could hold that, thank you. It has a fiberglass, a G10 fiberglass strip along, which is essentially affixed to both sides here. And that allows the joint to potentially bend, but of course is not going to bend at all because the load cell is preventing it from bending. So force is applied here at the elbow joint. So it has to be in that direction. So the force vector has to move into that direction, forcing the joints of legless Bob's arm to move apart that way. So that joint, that part of the arm moving that way, that part moving that way, and the force, a pulling force. So in other words, these two bolts are essentially, or I should say coach bolts, essentially want to pull apart due to the force exerted there, and that pulling force is registered with this load cell, which is appropriate to register that kind of pulling force. So, thank you. Quite simple, but effective. You'll also notice that I've put a high density EVA foam pad on the bottom, just to prevent hard contact with the fiberglass spring. You could call this a spring, really. That's how it's functioning. And it's mounted in turn on this mounting block, which I use for all kinds of things, including the impulse block. It can be raised or lowered on this beam by simply or loosening these two sections, threaded rod sections here, and then shift it up or down. So legless bob can be transitioned into armless George by just dropping the leg/arm down to the point where it's at ground level, and then you can be using it for various, essentially as a proxy to a leg. Of course, all force that is exerted into this joint must be sustained slow force, so this doesn't pick up impacts. This is purely for isometric holds, locks and holds that are applied into that joint. Okay, so the arm can be manipulated in various ways to simulate various locks and holds, breaking into that joint, to the side, etc. There's a lot of things that you can do with that configuration, and as I said, you can move it up and down the column. So the whole platform can be shifted up and down, as I've mentioned before. Can be shifted down so that it mimics the location of a leg, along with the knee joint, and various manipulations and tune-up applications that you can apply. It's a bit high at the moment, so I'm not going to be doing that, but you get the idea. In addition, and this is something that only occurred to me fairly recently, due to the basic kind of design, I can get some sort of feedback based on a sustained force applied into a weapon. So if you like, this becomes a simulation of a weapon strike, but with the sustained force that you might be exerting behind the weapon strike, in particular for like impact weapons. So holding in one arm, you can be applying force and getting a feedback on how much force you're applying. It's not going to represent the force applied here yet until the shoulder joint is, until I put a load cell into the shoulder joint, but it will provide you some kind of feedback which will scale with the amount of force that you apply. Can be with two hands, can be with a single hand, can be to the side, various side movements, can be up, and you can get a lot of sensible feedback from the system based on various weapon strikes. Again, that can be raised or lowered depending on your needs. Yeah, so actually a very useful platform for various types of training in sustained force application in martial arts, including weapon use. This is not optimal in terms of grip because of the wood blocks essentially that I've used, these MGP 10 pine battens. But if you were wanting to make this more specialized for weapon use, you could actually fashion a weapon handle. You could actually grind or sand down the wood into the right kind of diameter to make it, gripping a little bit more comfortable, if that was what you wanted to use it specifically for. Okay, so the Wushu Scientist is going to demonstrate some locks and holds, breaks into it. We'll have a look. 85 kilograms of force there into that joint. This is a lot more difficult because you can't reference your body mass. Over 40 kilograms there to the side.
Okay, and then we can do
more of like a triangular lock and break into the joint. Whoa! That went up to just under 100 kilograms.
Okay, and then we can also look at doing something like this.
So this is more of a lifting movement underneath the joint, capturing the joint, pushing up. Whoa, pretty good. Over 50 kilograms of force.
Yeah, I think that's about it.
Very nice. As I mentioned, there is still room for a lot of improvement in the design of legless bob. One of the aspects of legless bob that I find to be perfectly fine and acceptable, but that others may not, is that because of the use of rectangular cross-section MGP10 pine battens, it's not the most comfortable of surfaces to train against, especially when exerting high levels of force. So it has edges, and that can of course dig into the flesh. Now I don't actually mind that at all, because when I'm training I don't necessarily want to feel particularly comfortable. So I can get a little bit of body conditioning into the high force training, the isometric training as well. But other people may not want that and may want to opt for smoothing down the limbs, or using a different profile wooden batten, or even padding them. And those are all acceptable and won't impinge on legless bob's effectiveness as a training tool. Also, as I mentioned, I may want to, at some stage in the future, add a second load cell to the shoulder joint to allow force to be simultaneously monitored at both the elbow and the shoulder. This could allow for application of more internally complex techniques that seek to, for instance, bypass one joint and concentrate force into another. One could therefore monitor force in both the elbow and the shoulder simultaneously, and monitor how the balance of forces shifts between the two joints through subtle alteration of the internal aspects of a standard technique. However, this may prove to be needlessly complicating a simple and elegant design, so I'm still internally debating the merits of adding the extra load cell. Well, I hope this very simple design has been of interest to my viewers. We've been having a lot of fun trying it out. It's versatile and simple, and it's been of quite some benefit in terms of monitoring and improving the amount of force that we can exert in various grappling locks and holds. Let me know in the comments section below if you enjoyed this video, and if you want me to provide more construction details and upload the construction plan to our Wushu Workshop website. But as for now, that's the end of the video. Thank you for listening all the way through, and I hope to see you all again next time. Cheers!